So things didn't go as planned first period. A number of kids didn't know how to find the first 5 terms. You find the first 5 terms by plugging in numbers. Well, I don't know, I did this in notes. I think I was expecting you to remember how to do this. But if you want the first term, you plug in a 1. You get 4 minus 6, which is negative 2. If you want the second term, you plug in a 2. And that'll be 4 take away 12, which is negative 8. If you want the third term, you plug in a 3. And that'll be 4 minus 18, which is negative 14. And there's a pattern going on here. The difference so far has been negative 6, and it's been consistent. You are losing 6 things. So the next one is going to be negative 20, and the one after that is going to be negative 26. And again, I know some kids had issues with arithmetic here. The difference is going to be ace of 2 minus ace of 1, or ace of 3 minus ace of 2. So ace of 2 minus ace of 1 would be a negative 8 minus a negative 2, which is negative 6. And then we do negative 14 minus a negative 8, which is also negative 6. So it's consistent. It's what we call a common difference. So this is arithmetic. Mason, I cannot help you right now. That is arithmetic. All right, I also circled 2. If you want the first term, you plug in a 1. And that'll be 2 times 2 to the 0. And anything to the 0 is 1, so 2 times 1 is 2. If I want the second term, I plug in a 2. 2 minus 1 is 1. 2 times 2 is 4. If I want the third term, I plug in a 3. That's going to become 2 squared, which is 4. 2 times 4 is 8. Now, you can already tell here that there's no common difference here. Here the difference is 2. Here the difference is 4. We're doubling. The next term would be 16, and the fifth term would be 32. We are doubling as we move on. So this is not arithmetic. This is actually what you call geometric or exponential. All right, where did I circle next? I circled 5 next. Boys, please whisper. You are on YouTube, and YouTube hears you and not me. The whining you're doing, Mason, are you listening? The whining you're doing is being heard by the entire world. It's because Emmett is trying to play at the same time. It's a one-person board. Anyways, moving on, number 5. Write the explicit and recursive rule. Your recursive rules are always going to be in the form of the first term if n is 1, and the previous term, called a sub n minus 1, plus the difference if n is bigger than 1. So when I talk about the recursive rule for this one, the recursive rule would be the first term of a half if n is 1. And the next term would be a sub n minus 1 plus the difference. So what's the difference in these things? If you go to your calculator and you do 3/4 minus a half, it'll tell you 0.25, which is 1/4. So plus a quarter if n is greater than 1. This is your recursive rule. Your explicit rule is going to be written in the form a sub n equals a sub 1 plus parentheses n minus 1 times the common difference d. So feed the thing. Your first term is a half. Your difference we just found to be a quarter. And make this thing look like mx plus b. So we've got a half plus the distributive property, a quarter of n minus a quarter. Combine like terms, a half minus a quarter is a quarter. 1/4 of n plus a quarter. And there's 5. What I think is probably the hardest one on this piece of paper is number 7, because you got to do a whole lot on number 7. So you're told the 5th term is 5 and the 30th term is 30. The notes told you how to do this. The difference between ace of 30 and ace of 5 is 190. Sorry, 375. It's going to be negative 185 minus 190, which is negative 375. That's the difference between the terms. Now, the space between 5 and 30 is 25. There's 25 spaces where this happens. So your difference is going to be negative 375 over 25, which is negative 15. So I found that. Now, I'm supposed to write the explicit rule. This is why I found the difference, because I have that now, but I also need the first term. So if the fifth term is 190, I got to work my way back, and most kids won't write this out. They'll just push buttons in the calculator and figure out why they're doing it. You subtract 15 to move left, but you add 15, sorry, to move right, but you add 15 to move the other way. So this would be 205, this would be 220, 235, 250. That's your first term. So 250 plus n minus 1 times a negative 15. And then you just do the distributive property and clean it up. You'll get a negative 15n plus 15. You'll combine like terms and you'll be done. So the nth term is 265. Negative 15n plus 265. All right, moving forward, what's the next one I circled? 10, summation. So you're supposed to find the sum of the 6th term through the 50th term of 2n minus 2. So your summation formula says the sum of n things is n over 2 times the first term you care about plus the last term you care about. N will always be the high number minus the low number plus 1. That's going to be 45 and everything is said and done. And now we're going to plug things in to find the first term. The first term is actually called a sub 6. You find it by plugging in a 6. 12 minus 2 is 10. The last term is called a sub 50. You plug in a 50 and you get 98. So 45 for n. First term is 10. Last term is 98. Then you do math. I'm not feeling it right now. What do we got here? We got 45 over 2. Inside I can do, that's 108. 2,430. Mason, all of YouTube can hear you complaining. All right, the sum of the first 50 terms generated by the explicit rule is a sub n equals 16n minus 20. You're supposed to find this. I don't know why it doesn't say find. Find the sum of the first 50 terms. So this is n. Think about your formula. You're going to need n. But you're also going to need the first and last, which in this case is the first term a sub 1 and the last term a sub 50. So you go off to the side, you plug in a 1 to get the first term, and that'll give you a negative 4. And you go off to the side, and you plug in a 50 to get the last term. And that'll give you 780. That is not right. That is right. Yeah, that's right. 780. So plug in numbers. 50 over 2, negative 4 plus 780. And then you do math, kids. Or you push buttons, whatever. I know that's 25. And I know that's 776. If you don't know that, just push all the buttons. 19,400. And that's 12. The next three are 14, 15, and 16. So I noticed when you get about 15 and 16 is logarithms. 14, how many terms of the sequence negative 2, 3, 8 must be added to get 1,573? This one was kind of rough. The difference from term to term is that you add 5. So the difference is 5. that might be a big deal. I know the first term is -2, but I'm talking about adding things together, which means I'm talking about summation, the sum of n terms. N over 2 times the first term plus the last term. And n is the big question mark, right? Like, what is that? I don't know. That's the goal. And there's actually more to it than this one, because I know that this guy is -2, but like, what is this guy? That guy is a formula. So let's write down the explicit rule. We're going to plug into it. Believe me, I've taught math for a long time. I know that when you have to do 2 or 3 different things, I know exactly what happens to kids. But these are the standards you're supposed to learn. And we're going to plug some stuff into that. We're going to come up with something we can put in that question mark. So the first term is -2. Difference was 5, and we'll clean it up. We'll have 5n minus 5 minus a 2. And that's going to be 5n minus 7. And I can throw that right there. Let's see what we have now. Oh, one other thing I can do. That's the sum. 1,573 equals n over 2 times the first term of -2 plus that guy, 5n minus 7. And I'm just going to go through the cleanup process here. 1,573 equals n over 2, 5n minus 9. The easiest thing to do here to make your life a little easier is to multiply both sides by 2, because that will counteract the division on the right-hand side. If you take 1,573 and you double it, you get 3,146. And you're almost at an Algebra 1 level of math. Next, well, actually, this is Algebra 1 from here on out. Distribute. We'll have 3,146 equals 5n squared minus 9n. And if you have what we call a quadratic equation, you set the blasted thing equal to 0. And believe it or not, this thing does factor. I don't remember how it factors, but I know it factors. But if it doesn't factor, you can just do the quadratic formula. So it's x equals -b plus or minus square root b squared minus 4ac. All over 2a. So let's see what's in that radical. We have a -9 that has to be squared. Minus a 4 times a 5 times a -3,146. And that's what's in the radical. It turns out that has a square root. So 251. So x is 9 plus or minus 251, both pieces over 10. If you do the 9 plus, you get 260. 260 over 10 is 26. That's your end value. The other one's negative, because you'd have 242 over 10. That's negative 242 over 10, which is -24.2, which doesn't make sense because this is the position of the number. It doesn't make sense for there to be a -24.2 position. So 14 was pretty rough. It's got some Algebra 1 in it, quadratic formula. And I put 15 and 16 on here because y'all aren't done with logarithms yet. So 15 is solved by isolating. The thing I noticed on your test is most kids didn't want to isolate that. That's what we've been doing all year. I teach isolation. Isolate, isolate, isolate. Subtract 5. It's the easy thing you can do. You'll get a 16. 4 log base 4s of 3x minus 2 is 16. Divide out the 4. You'll have a singular log base 4 of 3x minus 2. The whole world can hear you crying. You get a 4. Now we're going to do log is base, argument. This is always a base. That's always an argument, which means this is going to be your exponent. You can have a base of 4, it gets raised to the 4th, and it equals 3x minus 2. 4 to the 4th is going to be 256. So 256 equals 3x minus 2. We're going to add 2 and get 258. And we're going to divide out that 3, and there's my answer. 16, again, isolate and then convert to a logarithm. We always isolate first. We subtract 5, we get 24. We divide out that 4, we'll have a 6 on the right-hand side. Oops, I divided out that 4. And then we'll do log as base. Bases have exponents. A couple of y'all haven't let that click yet. So base, exponent, argument done after isolation. We're going to have a log base 3. Its argument's going to be 6, and it's going to equal 2x minus 1. We're going to add 1 because we're still playing the isolation game. And we're solving for x here. I see a lot of kids who just like stop. The goal is to get x by itself. Tell me you don't understand algebra without telling me you don't understand algebra. If it says solve, you get x alone. That's what you do. So this is what x is, but it does say leave your answer in a form that you can evaluate using a calculator. So I'm going to do change of base. That would become ln of 6 over ln of 3 plus the 1 all over 2. Final answer. And there you go. I hope the kids weren't too disturbing.